Find the probability that a spin of the spinner below results in the arrow landing on a wedge with an even number or on a blue-colored wedge. Okay, so imagine you come along, you spin this spinner, you give it a good whack, and it spins around, and randomly lands on some wedge of the circle. The question is asking us to find a probability, so that's good. We know that it's a probability question. And again, it's just a spin, so it's a probability that one experiment turns out a certain way, right? So it's basically like one selection, but in this case it's one spin because we're spinning instead of selecting something. In fact, the arrow actually does the selecting, right? So after the arrow slows down and stops, finally it'll select a number for us at random. So it's basically like a random selection of one of the wedges below. And that's kind of how we should think about it, right? So it's basically find the probability that when you randomly select a wedge below, that wedge either has an even number or the color blue on it. So let's write a probability statement out. And I think we're going to say here that this is addition rule of probability. Why? Well, first of all, it says find the probability. Second of all, it's just one selection, right? So one spin or one selection that's occurring. And then finally, we have that word or, that key word that indicates addition rule of probability. So let's write out our probability statement. It'll be the probability that we spin an even, right? Or a blue. Okay, so the formula, when you know it's addition rule of probability, breaks down to this. The probability that the number is even plus, so wherever the word or is, we'll put plus the probability that we end up with a blue wedge, right? Minus the probability that we end up with both of these things at the same time. So what would that look like? Well, that would be a wedge, right? A wedge that is blue and has an even number, right? So I like to write that out because the concept of intersection sometimes is a little bit abstract until you actually put it in words, right? So what does it mean to do both things at the same time? It's a blue wedge that has an even number on it. All right, perfect. Now, once we have that expressed that way, then we have to write out the three fractions using that number of over total approach, right? So for each of them, we're going to do number of over total. Number of over total. And then number of over total. All right, so number of what? Number of evens, right? Over the total number of wedges, right? Wedges or spaces, right? Whatever you want to call those things. Then it'll be the same for all of the denominators, right? Total number of wedges right? Remember, the denominator for addition rule of probability doesn't change across the fractions. Once you set the first denominator, all your other fractions will have the same denominator. For the second fraction, it's the number of blue wedges, right? So a number of blues. And for the last one, it's the number of blue wedges with even numbers, right? So number of blues with even numbers on them. Okay, good. Now let's go ahead and do the counting part, right? So all we have to do now is just count these things up and we'll finish our problem, right? So our three fractions will be filled in and then we can use our calculator. All right, so the first thing, the simple thing, how many wedges are there total? Well, luckily they're numbered, so we don't even have to count them. There are 8 total wedges, right? So 8 is the denominator for all three fractions. Very good. Now what about the numerator for the first one? We need the number of wedges with an even number on them. So we have this one essentially, this one, and this one, right? So 4 or half of them, right, have an even number on them. Then for the next fraction, we need the number of blue wedges. Well, we can see clearly that there are 3 blue wedges, right? 1, 2, 3 there, so 3 blue wedges. And then finally, we need the number of blue wedges that also have even numbers on them. So you can see that that's this wedge and this wedge, the one with the 4 and the 6 on them. So that's 2 of those. And now we can just do some basic arithmetic. 4 plus 3 is 7. Take away 2 and you get 5. So the answer is 5/8, and you can just leave it that way, or you can get the decimal if you want that. So 5 divided by 8 is 0.625 if you work that out in your calculator, or if you do the arithmetic on paper. And that's our solution. So essentially the probability is 0.625 or 62.5% chance that when we spin this spinner, we end up on either an even numbered space or a blue space.